In this example, we're given a contingency table. This table shows a sample of cyclists and the routes they prefer in a biking tournament. We're going to let event F be females and H equal the hilly path, and we want to compute our answer. But to compute our answer, we need to fill out the rest of this table. Well, along each column and along each row, there's a total for each one. So we need to go through and just do a couple of quick additions right here. For example, we don't know the total who have gone the hilly path, but we know there were 32 female and 52 males who preferred this. So we're going to fill it out. Our answer in this case is 84 bikers preferred the hilly path. The number of total females isn't given directly, but in effect it is, because we're just simply going to add our totals right here of 45, 32, and 27. When we add those up, we find there were a total of 104 female bikers. So our total, if we add horizontally or if we add vertically, should be the same. We have a total of 194 bikers in the entire tournament. So, how do we find the probability that a biker chosen at random was either female or preferred the hilly path? Now, in this case, we do have to mention that these are non-mutually exclusive events. Why? Well, clearly there are some bikers who are both female and prefer the hilly path. So we can't say that being a female biker or taking the hilly path are mutually exclusive. So how do we handle that? Well, we're going to go through the set of steps right here. And we're going to employ the rule shown at the bottom right here. That is, if we want to find the probability that a biker was female or preferred the hilly path, we're going to add the two probabilities that the biker was female and that the biker went on the hilly path, preferred the hilly path, but we have to subtract from that the probability that the biker was both female and went on the hilly path, so we don't have an overlap of that count. So what is the probability of the biker being female? Well, there are 104 out of 194 females in this tournament. Those who prefer the hilly path, there were 84 out of all 194 who preferred the hilly path. Finally, how do we find those who are female and prefer the hilly path? Well, in this case, the lovely thing about a contingency table is that the number is right there. There were 32 who were both female and preferred the hilly path. So we can just simply pick that out of the lineup and put that right in our probability. So to get this probability, we're going to go ahead and we're going to get our rule to take the probability that they preferred the hilly path, so 84 out of 194. We're going to add that to the probability that the female was biker, so that biker was female, so that was 104 out of 194. A little math lexia there in my description, I apologize. And then finally we're going to subtract away 32 out of 194, our overlap of those who are both female and prefer the hilly path, and we're going to combine them all together. When we do that, 84 plus 104 minus 32 gives us 156. Since we're adding over the common denominator of 194, that would be our answer right here. Now we can put these in decimal form. As a matter of fact, on Canvas they ask you to do this. So if I were to round this to a decimal, 0.5431 was my probability of finding a female biker. 0.4416 was my probability of finding somebody who preferred the hilly path. Actually, my decimals are going to be a little bit off right here. I apologize. Let's see, 104, let's retry this. 104 divided by 194 0.5361. My apologies, everybody here. I'm going to have to really quickly change these. So 0.5361. I misread my notes right here. If I take 84 and divide it by 194, here it is, 0.4330 when we round up to 4 decimal places. If we take 32 and divide it by 194, we're going to be subtracting away 0.1649. And that means our overall probability, 156 divided by 194, is going to give us 0.8041 as our total probability.